I'm so sorry. I did not know my audio was off. So what I said was, you guys should just, each of these carbon atoms indicates their hybridization. Carbon number 1, you tell me carbon number 1 is this hybridization, carbon number 2 is this hybridization, and carbon number 3 is this hybridization. So we can move ahead. Sorry, my audio was off. I didn't know it was off. Let's do that quickly because there's no time. Okay, so I presume you can hear me now. So let's get to it. Sharp, sharp. So I would run this quickly. Okay, so carbon number 1 is sp3. Carbon number 2 is sp. Okay, carbon number 2 is sp2. That's from Omenazu, praise God. Your carbon number 1 is sp3. You said number 2 is sp. Okay, carbon number 3 is sp3. Okay, makes sense, and that's correct. So looking at it, remember I told you, just use the number of atoms that are attached to it. You just know the hybridization. This carbon, so count 1, 2, 3, 4. 4 things are attached to it, which means it's sp3 for this guy. This guy. And this particular guy is attached to 1 atom here. This guy is attached to 2, and it's attached to 3. So which means that this particular guy now would actually be exhibiting sp2 because it's attached to 1, 2, 3. So s1 and p2, 3. So you have that altogether. There are 3 orbitals here that are involved, and that's why you have 1, 2, 3 atoms. In this case, it's s1, 3. So sp3. So yeah, correct. So in this case, you have sp3. So that's correct, basically. So with this principle, just have in mind that the number of atoms, not carbon atoms, the number of atoms that are attached to a carbon atom will tell you the type of hybridization. If 4 atoms are attached to a carbon atom, it is sp3 hybridization. If 3 atoms are attached to a carbon atom, it is sp2. Then when you now have 2 atoms attached to a carbon atom, it means that it is sp hybridization. Okay, having said that, there's this final question I would like to put up so that I'll be sure, just to clarify, you guys are doing well. The final hybridization question. Okay, so yes, what is the hybridization in benzene, and hence what do you think is its shape? So let's answer this question quickly. Benzene, let me draw the structure of benzene so that everybody will flow with what we are doing. So the structure of benzene, as I told you guys in the last class, benzene is characterized by the delocalized double bonds. But let's just put down the structure. Basically, you have hydrogen, 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 hydrogen. The other structure that can represent benzene is this one, where you have, and you have something like this, like this, like this. Carbon, 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 carbon. You have H, 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 H. So what do we think? What do we think is the form of hybridization in benzene? Yes, our answers. So in benzene, what do we think? Yes. The form of hybridization in benzene, what do we think? Menazu Praise and Onyekachi Anyako. What do we think? Okay, Anyako says sp2. Yes. Yes, sp2 is correct. So let's explain why it is sp2. Every carbon atom in benzene is sp2. Let's explain why it is sp2. Let me remove this first. Oh yeah, so why is it sp2? It's very simple. If you look at the structure of benzene, let me just draw it again. Remember, all you need to do is count the number of atoms that is attached to the carbon and you will know the hybridization. This one, this hydrogen, 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 carbon, hydrogen, this carbon, hydrogen. Now notice something, uh, alternate. So you have that this carbon atom is only attached to one carbon atom here, two carbon atom here, and three. So which means each of these carbon atom is attached to three. Carbon here is attached to 1, 2, and 3. And when you have three atoms attached, the type of hybridization you have for three atoms is sp2. One will be S, then two will be P, and altogether you have three bonds formed. And that is why you have that three sigma bonds will be formed. Hence, in every carbon atom of benzene, each of these carbon atoms have three atoms attached to them. Hence, you have sp2 hybridization. I hope this is clear. Now, when you talk about the shape, I thought I mentioned it in sp3. Okay, let me just say that now. sp3 structure, you have a tetrahedral structure. In sp2, the shape formed around it is what we call a planar shape. So once you have an sp2 hybridized carbon atom, the shape formed around it is planar. And then finally, sp is linear. So please take note of these three shapes basically, so that when you are asked these questions, you would fully know what to answer. I hope this is clear. Now, having described all these things, the final thing, this is actually one of, you remember that we've been discussing, what we've been discussing so far are properties that make carbon special. We talked about catenation. We talked about the electronic configuration. And then we are talking about hybridization at this point. The next thing we are supposed to talk about is isomerism. Now, I am only going to define isomerism. I'm just going to define it. We are going to still get into the different parts of isomerism. We're going to discuss that later. But before we get into those parts of isomerism, I want us to understand naming first. You get. So I'm just going to define isomerism and possibly give you the branches. Isomerism is a phenomenon in which different compounds possess the same molecular formula. Some of your textbooks will now say but different structural formula or something like that. That's what your secondary school teacher might have taught you. But just have that in mind. Now, when they are talking about the same molecular formula but different structural formula, you are now referring to structural isomerism. The term isomerism simply describes a condition or a phenomenon in which different compounds possess the same molecular formula. Whether the difference is a result of their structure or orientation, it doesn't matter. The point is, once you have different compounds and their molecular formulas are the same thing, what is exhibited at that point is isomerism. So you have that. Isomerism is a phenomenon in which different compounds possess the same molecular formula. Now, see what I mean by isomerism. Imagine something like, let's use the very obvious one. Okay, maybe it's not very obvious to most people, but ethanol is represented by the chemical formula C2H5OH. This is ethanol. Methoxymethane is represented as CH3OCH3. If we are to look at the general molecular formula or look at the molecular formulas of these things representing them, you would have that you have how many carbon atoms are here? 2. How many total hydrogen atoms is 5 plus 1, which is H6. And how many oxygen? 1. In the case of methoxymethane, you also notice the same thing. 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen. Notice, these are 2 different compounds. However, their molecular formulas are the same thing, C2H6O, C2H6O. Hence, it indicates that these 2 are isomers. And this is the form of isomerism we refer to as functional isomerism. As I said, we are going to be discussing these things later in details. We're not going to talk about isomerism now. Why? I want us to understand the names of these compounds and how to name, so that when I say that methoxymethane is an isomer of ethanol, you would know what methoxymethane is. If I, for instance, say that pentanal is an isomer of pentanone. You will know what pentanal is and what pentanone is. So I'm not going to discuss it in details yet, but I'll just highlight some things. Isomerism can be generally classified into two: structural isomerism, isomerism, and stereoisomerism. Stereoisomerism. Under structural, there are 6 different forms of structural isomerism. The first one is chain isomerism. Second one is positional isomerism. Third one is functional isomerism. The fourth one is metamerism. The fifth one is tautomerism. And then the final one is ring chain isomerism. Then stereoisomerism basically has 2 types: geometric and finally optical isomerism. Now, as I said, I am not going to discuss this in details in today's class. We're going to discuss isomerism in details in another class after naming. We need to understand the different names so that when I mention a name, you can easily relate to it. So I'm going to pause my discussion on isomerism here and move on to the next thing. Now, the next thing I wanted to talk about, or the next part of your study, is elemental analysis. In elemental analysis, first of all, you need to understand empirical formula and molecular formula. And then the second thing you need to understand under elemental analysis or analysis generally is separation techniques. We will take the first part today and probably continue it in the next class. But before I move ahead, I hope what I said is clear. Is there any confusion with respect to what we've done so far? Those of you that are still in the class, make una talk. Yes, so let's talk. So I know that human beings are still with me. Please, can we have a class? Okay. Are you saying like extending today's class till tomorrow? That's canceling the class for today and moving it till tomorrow. Yes. Onyekati Anyako, are you saying we should continue tomorrow? Okay. So just to understand, are we saying like because it's already we should end the class today by 10:30. Let's see what we can cover yet before we end it. If we end it, continuation of the class, we'll talk about that later. Now, unless you people are feeling sleepy and you want to stop today and then we continue some other time, if that is the case, we can consider that. I need your responses. I dey wait to now. Let's just finish up for today. Then when we go to the WhatsApp group, we'll now discuss basically. Now, back to what I was saying. So the next part of today's class, we are done with the first part, and the next part we are supposed to talk about is how to resolve empirical formula questions. It seems like a very simple concept. It is actually a very simple concept, but I noticed that it can be very confusing. That's one of the reasons one of the things I would like to say. So one of the reasons I'm going to discuss this thing is because it is a very simple concept but can be very confusing. It's those confusing parts that I want to clarify so that we'll be able to move on with the class. Now, having said that, going back to our board, what is empirical formula? The first thing I would like to say is that empirical formula is the simplest chemical formula. Empirical formula is the simplest chemical formula that describes proportion of combining elements in a compound. I take it again. It is the simplest chemical formula that describes proportion of combining elements in a compound. Empirical formula will never give you the exact number. It will just give you a proportion. And when you say a proportion, it's like a ratio or something like that. Take for instance, I have a question and tell you that I have a basket of fruits, and inside that basket there are 30 fruits. There are 30 fruits, and the only fruits in that basket are mango and orange. If I ask for the, and I tell you that the proportion of mango to orange is 2 is to 1, does it mean that the total number of mango fruits there is 2? No. Does it mean that the total number of orange fruit there is 1? No. It's just giving you a proportion, and therefore that proportion will lead us to get the exact number, which is 20 is to 10. So empirical formula does not give the exact number, it only talks about a proportion. A very good illustration, or something that might help us imbibe this the more: the empirical formula of benzene is CH. Also, the empirical formula of ethyne is CH. How will you differentiate them? You can't differentiate them by the empirical formulas. What you use to differentiate them is their molecular formulas. Benzene's molecular formula is C6H6, while ethyne's molecular formula is C2H2. So have that in mind, that in elemental analysis, one of the major things we need to talk about is empirical formula, and it gives us proportion of combining elements. Now, why did I have to emphasize this definition? In some questions, they might just tell you that the proportion of carbon to hydrogen in a hydrocarbon is 1 is to 2 or 1 is to 3. Once you hear proportion, if they say that the proportion is 1 is to 2, automatically just know that the empirical formula will now be CH2. If I tell you that the proportion of carbon to hydrogen is 1 is to 4, it means that the empirical formula is 1 for carbon and 4 for hydrogen, and that's that. So basically, now your questions are actually not as simple as I just said. So let's look into 4 major things, or 4 major rules that must be applied for you to be able to solve any empirical formula question. So you can put that down if you are writing: rules to resolve empirical formula. The first rule is identify the combining elements. Identify the combining elements. I'm just going to outline them, then we take 1 or 2 questions, and then we continue some with the study. Okay, so yeah, as I said, let's put this down. It's important to write it. The first thing you need to do is to identify the combining elements. After you finish identifying the combining elements, you identify the mass or percentage compositions of combining elements. So what does this mean? The implication of this statement is that in some cases you will be given a mass composition, in some cases you'll be given a percentage composition. All you need to do is, once you finish identifying the elements, you indicate which of these has these percentage compositions. Now, after that, you go to the next, or the third thing. What is that third thing? Divide the mass or percentage compositions by the corresponding relative atomic masses of constituent elements. So after you finish identifying the percentage, you use the atomic masses of each of those elements to divide their percentage composition. So it has to correspond. We'll take a question to describe this. But there is something I need you to understand or note at this point. Now, what should be noted here is this. This particular procedure in step 3 is used to get what we call mole proportion. So step 3 is done to get mole proportion. Now, what do I mean by that? Why I had to state this thing here is because in some of the questions you might see, your composition might not be given in mass, neither will it be given in percentage. And when you have such scenarios, if it is given in moles, you don't need to do step 2 and step 3. I'll give you a question where you have something like that. Just have this in mind, that once you are given number of moles, take for instance, they tell you that you have 0.12 moles of carbon and 0.36 moles of hydrogen. Now, step 1 is carbon and hydrogen are identified. Step 2 is their percentage composition. Once they don't give you mass or percentage composition and what they give you is mole, you don't need to do step 2 and step 3. You don't need to divide by the atomic mass. Just put the mole ratios there, 0.12 and 0.36. The implication is step 3 is done to get this mole proportion. So once you are given number of moles, you don't need to do step 3 to find the mole proportion. I presume this is clear. If it is not clear, please ask your questions. Do you have any question with respect to this thing I just said? Any questions? If you have any question, please respond. Any question? Any questions, please? I need responses to this before I continue, because this is a very important aspect of this study. This is one of the places where we have some confusions from most students. Any question with respect to this? If not, I just want one response and then I move ahead. One response and I move ahead. Okay, very good. So let's continue. So just have that in mind, that if it is in moles, automatically you will know that you don't need to do step 3 again, because that step 3 is simply to get the mole proportion. Okay, let me just put that. So as I said, what you are noting is step 3 gives mole proportion. So once you have it in moles, you don't need to do step 2 and 3. Now let's continue. What is the final step? Step 4 is divide all the values from step 3 by the smallest value amongst them. So once you are done with step 3, you check amongst all of them, there has to be a smallest value. Use that smallest value to divide everybody. And once you do that, you have gotten your final answer. So basically, these are the 4 steps. And once you follow these 4 steps accordingly, there is practically no empirical formula question that you cannot answer. We're going to see to that, answer 1 or 2 questions on that, and then move ahead. Before we leave this, there are 2 things that must be noted after step 4. I'll just put that down. Now let me clear this and put that down. Now the things that you need to note after your final answer. Once you get your final answer, if any of the final values, is a 0.5 decimal, multiply all the values by 2. What do I mean? Imagine, for instance, you finish solving and then you get something like 1.5 and 2 as C and maybe H. The implication is, do not approximate 0.5 values. Once you have that one of the 2 final answers is 1.5 or 2.5 or anything 0.5, you simply multiply the 2 values by 2. So this will now be 1.5, this will now be 3, and this will now be 4. That's basically the principle behind it. Now once you have your final answers after the 4 steps, and one of your answers is a 0.5 decimal, you multiply all the values in that particular distance by 2. That is that basically. Now the second thing to note, which is also related to what I just mentioned, is if any of the final values is a 0.3 or 0.6 decimal, multiply all the values by 3. So once you have 0.3 or 0.6 as any of your final answers, or 1 point or 2 point or 10 point, anything 0.3 or anything 0.6, multiply all the values by 3 before you approximate. However, for other values, you can just approximate directly and you get your answers. Okay, so push into questions immediately to help us understand this. So we're going to solve like 4 questions on this or thereabouts, and then move ahead basically. Okay, let's put up the questions. Okay, so let's look at this question on the screen. That's the first question we're going to consider. So the question says an organic compound containing 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Calculate the empirical formula. So we can all see this question and let's answer it accordingly. So it says an organic compound contains 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Okay, let's get to solve this question. I'm going to take it out. Just look through it finally. I'll give you just 30 seconds. Take 30 seconds to look through it before I take this question down. Okay, so with that said, let's get to solve the question because I presume we've written them down, giving us time to write them down. Let's get into it. Okay, so let's solve. The first step in solving empirical formula is to identify the different constituent elements, and we have carbon, we have hydrogen, and we have oxygen. Very simple. Then the next step is to identify the percentage of mass composition. In this question, they give us percentage. Percentage of carbon here is 60%. Let's not bother putting the percentage sign. But if you noticed, under carbon, I wrote the 60. Under hydrogen, I'm going to write 13.3. And then finally, I have 26.7. Before you solve, check if the sum of all these things will give you 100. Let's check. 60, 13.3, 26.7. If it does not give you 100, it means somebody is missing there. So 1, 0, 1. Okay, so this is 100. 0, 1. Very good. This is point. And you have that. So you will notice something. We all notice that our sum of everything gave us 100, which means we can go ahead. Now, after you are done identifying the percentage compositions, because they did not give us as mole, we need to apply step 3. Step 3 now says divide each of them by their corresponding atomic masses. Atomic mass of carbon is 12, so divide by 12. That of hydrogen is 1, so divide by 1. That of oxygen is 16, divide by 16. If we do this, what are we going to get? 60 over 12 is supposed to be 5. 13.1 over 1 is 13.3 over 1 is 13.3, and then 26.7 divided by 16 is going to give us 1.66. Now it's important that you use at least 3 decimal places, so that's going to be 1.669. Now this is step 3. Then we go to the final step. Use the smallest value amongst them to divide everybody. The smallest value here is 1.669. So I'm dividing by 1.669. I'm dividing by 1.669. I'm dividing by 1.669. Okay, so dividing through, that's going to be 5 divided by 1.669, and that's like 2.9. 2.9 is 2.99 is approximately 3. We can approximate 9.9. The ones we can't approximate are 0.5, 0.3, and 0.6. Then we have 13.3 divided by 1.669, and what we have is 7.9, which is approximately 8. And finally, 1.669 divided will give us 1. So our empirical formula will now be C. So empirical formula will now be C, 3 of them, H8, and 1 of oxygen. And that's that basically. So if we look at our options, that is going to be option number B, and that's that basically. Any questions so far with respect to what we've done? Any question? Those of you that are still awake, any question? Okay, any questions so far? I just need one response. Okay, very good. Now, you guys should try out this question. Quickly resolve this question quickly. Try out this question quickly. Okay, so resolve this question. This is a question for you guys. Solve it quickly. You have 1 minute to solve it. Once I have one answer, I would solve. Just need one answer and I will solve. So solve, everybody. The both of you in the class, just solve, basically. Okay, we don't get answer. Okay, we said this is sorry. Yeah, correct. I think C is correct. Yes. I presume I don't need to solve, but let me just quickly run through it just to confirm with you guys. Let me just quickly run through it. Yeah, where is this guy? That question. Okay, so resolving it quickly. So resolving it quickly, they said the hydrocarbon, which means carbon and hydrogen. I think here was 88.9, which means it's not up to 100. So here is 11.1. Once you hydrocarbon, it means it's only carbon and hydrogen. Divided by 12, divided by 1. So dividing that quickly, we are going to have it's 8.9 divided by 12. So here you have 7.408. And here you have 11.1. So dividing through 11.1 divided by 7.408, what you have here. So here is approximately 1.5. And here you have 1. Oh, sorry. I'm just solving this thing for those of them that so this is step 1. We have done step 2. This is step 3. Then after step 3, use the smallest value amongst them to divide, which is 7.408. 7.408. Yeah, you could have used 7.4. It's still the same thing. You get 1 here and 1.5. But remember, we said that once you have a 0.5 value, you multiply both of them by 2. And this is going to be 2, and here will be 3. Hence, our empirical formula will be C2 C2H3, as we said. Okay, so that's that basically. Now, having mentioned this, there is this other version of empirical formula or question I noticed. I just want us to just look at it briefly before we talk about molecular formula and possibly call it off for today. Let's look at this particular question. What do we think is going to happen in this particular question? This is going to be our assignment. I'm going to send it to the group. You give me your answer later. I'm going to briefly talk about molecular formula and then we'll call it off for today. Now, molecular formula is simply gotten by multiplying the empirical formula by a factor. You get, I just call this a factor. MF means molecular formula, empirical formula is EF. So if, for instance, they say what's the empirical formula? Empirical formula will now be that C2H3 multiplied by the value of N. How do we find this value of N? Very simple. To find the value of N, all we need to do, so as I said, molecular formula is equals empirical formula multiplied by N. And how do you get N? N is simply given by molar mass all over empirical mass. The molar mass is usually going to be given to you in most cases. And the empirical mass is simply the mass of the empirical formula. So if you have C2H3 and they say what is the empirical mass of C2H3, it's simple. What's it going to be? You have carbon is 12. 12. How many of these 12 do you have? 12 times 2. Plus you add it to hydrogen. Hydrogen is 1. How many do you have? 1 times 3. If you put this together, this is going to be 12 times 2, which is going to be 24 plus 3. And this is all going to give us 27. And that is how to find the empirical mass. So empirical mass simply means add the different atomic mass in the empirical formula and you get the empirical mass. The molar mass is most likely going to be given to you. Now, in a scenario where you are not given the molar mass, the other thing that can be given is vapor density. So what do you do with the vapor density? Molar mass is related to vapor density as molar mass is equals vapor density multiplied by 2. So the implication of this statement is this, that whenever you are asked to find N, N will now be given as, if you don't have molar mass, N will now be given as vapor density times 2 all divided by empirical mass. Or you simply find the molar mass by multiplying the vapor density by 2. And once you do that, you divide it by the empirical mass and you have that. So that's that basically. I hope this is not confusing. So have that in mind, that if they don't give you your molar mass and they give you vapor density, how do you convert the vapor density to molar mass? Simply multiply that vapor density by 2 and you have your molar mass. That's that basically. So you have N is equals molar mass over empirical mass, or N is equals vapor density times 2 all over empirical mass. Now, the other thing that can be done with respect to molecular formula, or the other thing that can be given with respect to molecular formula. So this is one of the formulas. This is the second one to find N. And this is how to relate molar mass to vapor density. Now, the third way they can twist the question is, instead of giving you the molar mass or giving you vapor density, they will give you volume and mass. How do you relate mass and volume to molar mass? It's quite simple. If you know stoichiometry or you did stoichiometry well in the last semester, you will know that the relationship between mass and volume is mass over molar mass is equals volume in dmq all over 22.4, or mass over molar mass is equals volume in cmq all over 22,400. Now, all you simply need to do with respect to these two is make molar mass the subject of formula. So when you are looking for the molar mass, it's now going to be mass times 22.4 all over volume in dmq. I'm just giving you the different ways to find the molar mass, just in case you have a question where the molar mass is not given directly. What do you do to find the molar mass? If you are given vapor density, what do you have to do? Vapor density times 2 and you get the molar mass. But in a scenario where you are not given vapor density and what they give you is mass and volume, simply use this relation. Molar mass is equals mass times 22.4 all over volume in dm3. Or if it is in cm3, you will now do molar mass is equals mass times 22,400 all over volume in cm cubed. So it's important to take note of these things. So put down these formulas so that we can be able to go on with 1 or 2 questions and then call it up for the night. But before I move ahead, is there any confusion? Any question or any confusion so far? Any confusion so far? Any questions so far? If none, just need one answer so that I can continue. If none, we can move ahead. If none, we can move ahead. Is there any confusion? Okay. So praise and Anyaku. May una just try click like button because una don dey this class since. Una no click like button. Una click like button. Secondly, if una never subscribe, una subscribe. It's important. Anyway, let's continue. Now we're going to try 1 or 2 questions. You get, just to help us understand this the more. Let's see. Let me put up a question. Just to. Okay. Oh yeah. Okay. Let's try this question. So I'm going to solve this one and then give you guys one to solve. Basically do that way. Okay, so the question simply says an organic compound has an empirical formula of C2 CH2O and a vapor density of 45. What is the molecular formula? So you notice in this question now, they gave us the empirical formula and said we should find the molecular formula. Very simple. So how do we solve this thing? I'm going to solve it on the side. So we have that the empirical formula that was given. If you are looking for molecular formula, is simply given as empirical formula multiplied by n. And in this question, the empirical formula that was given is CH2O bracket n. So let's find our n value. Now our n value is going to be easy to find. And what is it? Molar mass divided by empirical mass. In the question, we were not given the molar mass, but we are given vapor density. And we are told that when you are given vapor density, how do you convert it to molar mass? You simply do vapor density times 2. Vapor density times 2 all over empirical mass. So let's look at this now. What is the molar mass going to be in this question? 45 times 2, and that is 90 gram per mole. And the empirical mass in this question, what is it going to be? The empirical mass is an addition of this thing, which is 12 plus 1 times 2 plus 16. And if we do that, this is 12 plus 2, 14 plus 16, and that will give us 30. Hence, the value of n is now going to be 90 divided by 30. If we cancel out, this is going to give us 3. So what do we do with this now? The molecular formula will now be simply equals CH2O all multiplied by 3. And that is going to be molecular formula equals C3H6O3. And that's our answer. So that should be option, yes, option C, basically. And that's our answer. Quite simple to solve. I presume this is easily understood. Is there any confusion? Any question, any confusion so far? Okay. I just want one answer, so we'll move ahead basically. Is there any confusion or any question so far? Okay, very good. So you guys should just try this question. I'll be giving you guys 2 questions or 2 more. We'll solve like 2 more questions and then we'll call it off for today. Okay, where is it? Let's get the question. Okay. Oh yeah, attempt this question. You guys should try this. Okay, you guys should try this question. Try solving this question. You have 1 minute to solve it. Just 1 minute to solve it, and then we would call it off for today, basically. So try this question. If you don't get it, I'm going to solve it, resolve it, and then we'll move ahead quickly. You have 1 minute. It's a very simple question. Okay, Onyekachi Anyaku, you are likely correct. Let me solve to just clarify this. Let me just solve to just clarify this. So I'm going to like let me just yeah. So do I need to remove this? We all have the question, so let me remove the question from the screen so that I can have the full board to myself basically. Okay, so that should be it. Removed. Okay, so let's solve this question. First of all, is I told you guys that once you hear proportion or ratio, the implication is that they have given you the empirical formula. So they said the molar ratio of carbon to hydrogen is 1:2. So which means the empirical formula is 1:2. That's what it means. Good. And they say we should find molecular formula. Molecular formula is equals molar mass divided by empirical mass. First thing we need to find is the molar mass. And how do we find the molar mass? If you look at the question, they gave us 0.12 gram of the liquid and told us that the volume is 32 cm cube. I told you that if, for instance, they don't give you your molar mass directly and they give you volume and mass, how do you resolve it? It will be mass times 22,400 all over volume in cm cube. That is how to find the molar mass. Learn this formula, cram it. I don't know how you're going to put it, but just put it into your head. I've established this relation in our stoichiometric study, so you can look up my stoichiometric video to understand this thing better, but just have this in mind. So the mass they give us is 0.12 gram multiplied by 22,400 all divided by the volume in cm cube, which is 32. Now if you do this, the molar mass we are going to get is now going to be, let's use our calculator to resolve this. Calculator, and we have 0.12 multiplied by 22,400 divided by 32. And once you do that, your answer for the molar mass is going to be 84 gram per mole. Now, let's find the empirical mass. The empirical mass is simply an addition of all these things, and that's going to be 12 plus 1 times 2. And once you do that, what you have here is 14. Now, let's get to work. The molecular formula. Oh, no, sorry. I think there's a, sorry, this is not the molecular formula. This is simply to find N. So remember, molecular formula is equals empirical formula multiplied by n. So let's get to work. So we've gotten that n will now be equals what? What's the molar mass we just got here? 84 divided by the empirical mass, which is 14. And when you do 84 over 14, I think what you should get is 6. And once you have that, you now apply it here. The molecular formula will now be simply equals empirical formula, which is CH2, multiplied by n, which is in this case 6. If you do that, it will be C6H12. And that's our answer. I hope this is a very simple concept that anybody can be able to resolve. Um, uh, Praise. I hope you've seen the correction, Praise, because you said B. Just respond. Praise, respond if you've seen the correction. So that we go. Okay. So with that said, I think we can. We're going to call it off for today. I'll send you assignments to the group. You get, so resolve those questions in the group. We would discuss on how regular these classes will be there. Thank you very much for watching. Please don't forget to subscribe to my YouTube channel. It's Waits Lounge. You have so many other studies there if you want to. Praise, answer. Okay, very good. We'll call it off for today. Good night, everybody. Do have a very wonderful sleep.